Section 1.6, Exponential Notation and the Order of Operations Agreement. Okay, what you have here is an exponent. You'll notice that we have 4 times 4 times 4 times 4 times 4, which is also equal to 4 to the 5th. The 5th power is known as the exponent. It is a superscript after the 4, which is known as the base. 4 to the 5th is known as exponential notation. Some commonly used powers, such as the second power and the third power, are shown here. Take a look at the top row. We have 7 to the first power. That is typically just read as 7, or the number base itself. The 1 is implied. And then we have the second row, 7 squared, or 7 to the second power. Squared is the commonly used term for anything raised to the second power. And then finally, the third row, we have 7 cubed, or 7 to the third power. Again, cubed is the commonly used term for the third power. Anything higher than the third power is typically just the number itself. So for example, 7 to the fourth power, 7 to the fifth power, and so on. Now the number 10 is kind of neat. When you have a base of 10 raised to an exponent, you basically just count the number of zeros that you need. So for example, 10 to the first power equals 10, and 10 has exactly 1 0. 10 squared, or 10 to the second power, is equal to 100 because it's 10 times 10. Again, the number 100 has 2 zeros in it. 10 cubed, or 10 to the third power, has 3 zeros. Again, because it's to the third power, or 10 times 10 times 10. 10 to the fourth power has 4 zeros, it's 10,000. 10 to the fifth power has 5 zeros, it's 100,000, and so on. Kind of neat. Before we try some examples, let's try simplifying a numerical expression containing exponents. For example, let's say the problem says, simplify 4 to the third power. Well, let's start by writing it out as 4 times 4 times 4, and then just multiply 4 times 4, which is 16, and then times another 4. That gives you 64. Okay, so write it out in steps. Okay, another example, which you'll notice combines 2 bases with corresponding exponents. We have 2 squared times 3 to the fourth. The first thing you want to do is write out 2 squared as 2 times 2, and notice that I grouped it, times 3 times 3 times 3 times 3. After you do that, you want to actually simplify 2 times 2 and 3 times 3 times 3 times 3. 2 times 2 is simply 4, 3 times 3 is 9, 9 times 3 is 27, and then 27 times 3 is 81. And then finally, you're going to multiply 4 times 81 together, and you get your final result, 324. Okay, let's try example 1. Write 2 times 2 times 2 times 2 times 3 times 3 times 3 in exponential notation. Notice we're not simplifying, we are simply rewriting this. It's currently expanded, and we want to write it using exponential notation. This is simple. All you have to do is count the number of 2's, there are 4 of them, and write it as 2 to the fourth times 3 to the third. There are 3 3's. Easy enough. On to example 2. Write as a power of 10, 10 times 10 times 10 times 10 times 10 times 10 times 10. How many 10's are there? 7. So the answer is simply 10 to the 7th. Now, if I asked you to simplify or write out the final number answer, it would be 10 million. And the reason I knew that is because there are 7 zeros in the number. Now let's try example 3. Simplify 2 cubed times 5 squared. Now, it's actually saying to simplify, so we want a number answer. Well, let's start by writing out 2 cubed as 2 times 2 times 2 and 5 squared as 5 times 5, like we did previously. 2 times 2 times 2 is 8. 2 times 2 is 4. 4 times 2 is 8. And then 5 times 5 is 25. So we have 8 times 25. Now, see if you can do that in your head. Think about money. How much money would 8 quarters be? Or even easier, how much money would 4 quarters be? Well, that would be $1, or 100 cents. And if we double that, that would be 200 cents. So 8 times 25 is simply 200. Try to do as much mental math as you possibly can. Okay, let's move away from exponents for just a little bit, at least for now. And let's talk about order of operations. Now keep in mind, exponents definitely play a role in the order of operations, but this one does not. Let's just try a simple problem. We have 3 plus 4 times 5. Now, if you were to ask somebody to simplify this problem on Facebook, you'd probably get two distinct answers. One of them is probably going to be 23, and the other will be 35. Which one do you think is correct? Only one is possible. Well, according to the order of operations, multiplication comes before addition. So, the correct way to simplify this expression is to first focus on the 4 times 5. Even though it comes after the addition, you still do it first. So we get 4 times 5, which is 20, and then finally 3 plus that 20 equals 23. That is the correct answer. Some people, however, no matter what the operation is, will work from left to right, and that is not always the correct case. Actually, in many cases, it's not correct. So the other answer you'd probably get would be 7. So you would do the 3 plus 4 first, and then multiply it by the 5 at the end, and end up with 35. Notice you have two different answers. You cannot have the same mathematical expression equal two different numbers. Therefore, 23 is the correct answer and the only correct answer. Okay, the order of operations. You have probably seen this before at some point in your life. We have PEMDAS, which some people call PEMDAS. You may have even heard, please excuse my dear Aunt Sally. Well, let's go in order of priority. Well, starting with the P, we have parentheses. And what that means is if you have any expressions inside of the parentheses that can be simplified themselves, you want to do that first. If it's a single number inside of parentheses, don't worry about it. It's just a single number, most likely being multiplied by another number. But if it's an expression on the inside of the parentheses that can be simplified, that's what you do first and foremost. The second is exponents. If you have any exponents within the expression, you want to simplify those next. Then you'll see M and D. They stand for multiplication and division. And notice that I have written there equal priority, meaning that let's say you have 8 divided by 2 times 4. You would not do the multiplication first. You would simply work from left to right. So even if a division comes before multiplication, you still do that first. Multiplication and division are equal in terms of priority. And then we have addition and subtraction. Those also have equal priority with each other. So again, if you have 7 minus 2 plus 11, you would not do the addition first. You would do the subtraction first, work from left to right. Here are the examples I was talking about when I explained PEMDAS. On the top, you'll see a multiplication and division problem in terms of order of operations. And notice that we are working from left to right. We have 8 divided by 2, which gives us 4, and then 4 times 4 equals 16. If we were to change it up and do multiplication first, we would get 2 times 4, which is 8, and then we would have 8 divided by 8, which actually equals 1. That is incorrect. If you take a look at the bottom, we have 7 minus 2 plus 11. Again, addition and subtraction would go equally in hand. So we're going to do 7 minus 2, which gives us 5, plus 11 equals 16. And again, if we did 2 plus 11 and get 13, and then do 7 minus 13, we're going to get negative 6. So also, we want to work from left to right. Just remember equal priority for multiplication and division, and equal priority for addition and subtraction. Alrighty, let's try an example involving the order of operations. We're going to put all of them together. Alright, let's simplify the following problem. 3 times the quantity 2 plus 1 minus 2 squared plus 4 divided by 2. Okay, so let's think about this. What's our first step? Well, do we have any parentheses to simplify? Yes, we do. We have the quantity 2 plus 1. So all I'm going to do in the first step is simplify the parentheses, 2 plus 1. I'm rewriting everything else the same exact way. So we have 3 times 3, and then minus 2 squared plus 4 divided by 2. Okay, the next step is, are there any exponents? Yes, there is. So we are going to simplify the 2 squared. Everything else I'm going to rewrite. So we have 3 times 3 minus 4 plus 4 divided by 2. The next question you want to ask yourself is, are there any multiplication or division symbols? There is a multiplication here and a division here. You can do both at the same time, but just ignore all the addition and subtraction signs. So we're going to do 3 times 3, which gives us 9, and 4 divided by 2, which gives us 2. Notice I just rewrote the minus 4 and the plus. And then finally, just add and subtract from left to right. So 9 minus 4 gives us 5, and then 5 plus 2 gives us 7. That's our final answer. Okay, let's have you try a few problems on your own. See how you do with them. Number 1, 64 divided by the quantity 8 minus 4 squared times 9 minus 5 squared. Be careful, take it step by step, and remember the order of operations. Number 2, 5 times the quantity 8 minus 4 squared divided by 4 minus 2. Just take a few minutes and then you can see the answers. Here's the step-by-step answer explanation for number 1. Do we have any parentheses? Yes, we do. 8 minus 4. So the very first thing I did was simplify 8 minus 4. Everything else you'll notice is written the same exact way. 64 divided by 4 squared times 9 minus 5 squared. The next question is, are there any exponents? There are 2, 4 squared and 5 squared. So, rewriting everything else the same exact way, I have 64 divided by 16 times 9 minus 25. So 4 squared and 5 squared were both evaluated. The next question is, are there any division or multiplication portions? There's a division and a multiplication. You work from left to right. So the first thing I did was 64 divided by 16, which is 4. So that's what I did here. 4 times 9 minus 25. And then I did 4 times 9, which is 36, minus 25, which equals an answer of 11. Okay, and then for number 2, parentheses, we have 8 minus 4. So we have 5 times 4 squared divided by 4 minus 2. The next step, exponents, we have one exponent. So we have 5 times 16 divided by 4 minus 2. The next step is multiplication and division, working from left to right. We have 5 times 16 divided by 4. The first thing I did was the 5 times 16, which gives us 80. So we have 80 divided by 4 minus 2. 80 divided by 4 gives us 20, so we have 20 minus 2, and our final answer is 18.